Okay, so we're going to be moving on to the 28th problem in the grind 75. This one is called K closest points to origin. So we are given 30 minutes. So let's pull up the timer. So we'll start the countdown now. Okay, so Wi-Fi should be okay. Nice daily check-in. This is taking quite a while. Okay. Given an array of points where points at some index is equal to x at that index and y at that index, where points represents a point on the xy plane and an integer k, return the k closest points to the origin 0, 0. The distance between 2 points on the xy plane is the Euclidean distance, i.e. x1 minus x2 squared plus y1 minus y2 squared. Yes. You may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. Okay, so let's see. So we're given an array of points and we want to find the k closest one. So whatever k is, that's how many closest ones we want to find. K, okay. So we know that our array of points will always be greater than or equal to 1. Same for k will always be greater than or equal to 1. And k can potentially be points.length too. And our points can be any digit really. So this doesn't seem too bad. We will have to do the square root function, which I guess we can do exponent to the 1/2. I don't believe that was really said properly, but so let's see. So the closest point to the origin. So basically we're going to have to iterate through the entire array and calculate the Euclidean distance. So I'll just write that down. Iterate over array, calculate Euclidean distance of each point. And let's see. So we want to have k points, right? So if we were to just get, if k was equal to 1, that would be easy. We could just get the smallest overall. But we want to get the k smallest ones. So how can we do that? Let's see. So I don't really know if this is the greatest way to do it. No, that sounds pretty expensive. My initial thought was to make a hash map where the key would be the index of the point and the value would be its Euclidean distance. And we would essentially have to iterate over the set and get the minimum and remove it from the set, and then we would decrement k. And once k equals 0, then we would have enough points. And let's see, so we have to return an integer array too. So let's see. The way I like to return integer arrays of arrays is to actually create my own linked list of integer arrays. That's especially useful for building because we don't have to create an array list, which could take up unnecessary memory. We can just add integer lists as we go. So, I mean, I'll just write that out for right now. It's going to be an int array list. This will be equal to result. And we're just going to say new linked list with the same dynamic type as static type. So let's see. Okay. So we get the distance, right? Return the k closest points to the origin 0. Trying to enter in any order. Is there a more efficient way to do it than the way I just said? I'll actually make a note of it. So hash set with index as the key and distance as the value. Then, while k is less than what is it? Okay, actually, I think I know what I want to do. I've never implemented this before, so I'm not sure how it would work, but basically what I want to do is create a min heap, right? Because, yeah. So a min heap is just a collection of points that has the minimum value on top. And as soon as I grab the minimum value, it will be replaced, that top node will be replaced by the next minimum value, and so on. I guess it's also called a priority queue. And we would need some sort of key value pair though. And the priority queue would, in our case, have to be the, what is it? The value of, the Euclidean distance. So I'm not really, I've never done this in Java or really any language before, so I'm not sure what that looks like syntactically, but just conceptually, I know this would probably be the time to use a priority queue. I know there's some built-in method in Java or built-in class called priority queue, which I believe implements the queue interface, which again implements the collections interface, and we know some of the collections interface's methods. So maybe we can okay. So peak is pop top. Okay, I'm so how would we priority queue of hashed.entries? Is that how we would do it in Java? If we want key value pairs, but then how do we know what to order the priority queue by? I know that we want it to be Euclidean distance. In that case, maybe we would make the Euclidean distance the key, actually. Distance as the key, and then index as the value. That could work. I'm not really sure what the priority queue would look at if we're passing in key value pairs like this. So yeah, this is, I believe, the right way to do it. It might be a little fancy syntactically, but I think this is, yeah, one way to do it. So basically we're going to iterate over entire array, add everything. So the time complexity will be O of n, because fortunately we will have to go through the entire array, but that will be the bottleneck. Finding the minimum from there will essentially be constant time, where, yeah, technically the highest it could be is n, because k could be equal to n, and we'd be doing, well, no, yeah, we'd be doing n constant time operations. But all right, so I'm just going to do it how I believe it should be done. Syntactically, we probably won't get there. So for int I, for as long as I is less than points.length, I'm going to increment I by 1 each time. We are going to say int distance is equal to points. So looking at the formula, it's basically going to be, since we're trying to get the distance from 0, it's going to be points at index 0 squared plus points at index 1 also squared, and all of this is going to be to the 1/2, or square rooted. I believe this is the right way to do it in Java. Okay, so cool, that gets the distances. Now what we want to do is, which we'll actually define up here. Does it have to be? This might be fancier than necessary, but we're going to say priority queue, and this is going to be of hash set dot entry. I know this is a key value pair. I don't know if this is legal though. This is going to be min dist heap. That's what it is going to be, and we're going to set it to the same version as our static type. Okay, and then we are going to say min dist heap dot, because priority queue eventually goes back to collections, I believe we can do add, and I'm going to add, actually let me instantiate it first, not int, it's going to be hash set dot entry key val, I guess dist end would be more accurate. That's going to be equal to distance first. So what would that even look syntactically? Do we use curly braces? See, if we were to just use integer arrays of size 2, That would be nice, but I have really no understanding right now of how the priority queue orders its internal values. However, I know if we use a hash set, the key seems to take precedence, so I'm more confident that it would order that properly. Also, how do we even know that this is ordering, this has minimum nodes at the top and then larger ones at the bottom? How do you even set that? And what gives it the priority? Is it even the value or is it something else? Can you have multiple value? Okay, I shouldn't be asking these. I should know this. Okay. So I'm just going to finish this really quick in a conceptual manner. I'm not really going to run it because I'm pretty sure these methods aren't really right, but I'm just going to write out how it should be done. You know, if these were the actual names of the methods and so on. Okay, so hash set.entry dist_int is going to be equal to distance for the key and then the index for the value, and then we were going to add dist_end. Okay, and then from there we're just going to say while k is, so let's see, greater than 0, is that right? So if we want 2 points, k will be 2, then we'll get a point, decrement 2, get a point, decrement it, be 0, we'll stop there. So yes, we'll say while k is greater than 0, we are going to say hash set dot entry. Also, it's not even a hash set. It should be a hash map. Okay. Again, this is probably not how you would do it, but I know for a fact it should be a hash map because the set only collects that one value when we've been wanting key value pairs the whole time. So while k is greater than or equal to 0, hash map dot entry, let's say cur minimum distance is equal to min dist heap dot pop, if that's the right method. And then we'll decrement k. But before we do that, we should actually add it to our result. So result dot add cur min dist. Also, is that even allowed? I'm just trying to think back to how I did it for a previous problem. Well, okay. So this, I believe, actually is the syntax for if you were to create an integer array in Java and give it some value. So I'm just going to assume that an integer array has pretty much like the same functionality as this. Again, we're not really going to run it, but we're just getting the conceptual part down. So we're going to add for in distance. Okay, and that's good. And then basically in the end, we'd have to do toArray, where we create a new integer equal to, well, if we don't maintain the original k, then what should we actually be saying? We can iterate through. Okay, so 0, 1, 2. Yeah, we could just do that actually. So I'm gonna say for int j is equal to 0 for as long as j is less than k, we'll increment j. We're going to do it just that many times so that we don't decrement j, or k, I mean, because we want our integer array to have k entries, and then each entry should have a size of 2. Okay, and so if I knew the proper syntax, I probably would be able to come up with a solution to this. And I believe this is the solution. I don't really know. There might be some way that you can go faster, but it seems like you do have to touch every point in order to find out if it is one of the smallest, has one of the smallest distances from the origin. So it seems like an O of n solution is really the best you can do. And yeah, I'm not really going to think about it anymore. We'll see you in the solution.